Let's have a look at the first assignment that you have to do with Activity 2 in the electricity unit. We're going to be making circuits, and in the first assignment, you'll be making parallel circuits using the PhET simulation. I just copied the circuit that you're going to start out with, and you'll build this on PhET and then find the current through the battery and through each light bulb, and then you also want to find the voltage across the battery and across each light bulb. So to use the ammeter, you can either put an ammeter in right beside the light bulbs. You can break this and put the ammeter in that goes in the circuit, and then break this and put an ammeter in that goes here. Or if you want to, you can also use there's an ammeter that you can just use to hold over the circuit to measure the amps or current at each point. When you use the voltmeter, you'll have to put the voltmeter around an object. So you put the ammeter right beside each of the devices to see what the current is going into the device or going through the device. And the voltmeter, there's a positive and a negative, and you have to put the voltmeter around. So make sure that you do that. So let's just say that you should, for the voltage, you should see that the voltage is 9 volts for this, 9 volts for that first light bulb, and we'll call this the total, and the voltage for the second bulb is 9 volts. Our current of the battery is 1.8 amps when you measure it. The current just going through light bulb 1 is 0.9 amps, and just going through light bulb 2 is 0.9 amps. So you just want to go back to what we talked about in that review with the formulas for a parallel circuit and compare your answers to see if they match up. So for the parallel circuit, we had 3 formulas. I'm just going to quickly write them down. Current is the sum of all the currents in all the paths. So in parallel, we have multiple paths. I'll just show 2, but if you had 3, you'd keep going. Voltage is the same in every path. So the total voltage is going to be the same in path 1 and the same in path 2. And if you had more paths, the voltage would be the same in each of those paths. And then the resistance is a little bit of a tricky one. It's 1 over the total resistance is equal to 1 over that first resistance plus 1 over the second, plus, that's a 1 over, not a plus, plus 1 over any other resistances that you might have. So you want to take your results that you saw in the simulation when you actually measured all of these things and compare them to these equations for the parallel circuit in question 1 and 2. So just see, does that hold true? Is the voltage the same everywhere? And do the currents add to give me the total current? In question 3, you want to predict the current flow if we add another light bulb to this circuit. So we want to predict. And when you're predicting, if you don't get it right, that's fine. I just mark your reasoning. So it's fine if you don't have the exact right answer, and then you find out in question 4, when you actually have to build it and measure it, that you were wrong, and then you can explain. That's fine. That's part of the learning process of science. So in this circuit, we want to predict what's going to happen when I add a third light bulb. So the total current actually changes whenever we add a third light bulb, because it's like adding a new road when you have traffic. So the electrons are going around, these are like roads for traffic, and when you open up a new road, then you can actually accommodate more traffic or more flow. But we want to use the current law, Kirchhoff's current law, which is right here, to explain it. And then in questions 5 and 6, you're going to build a completely different circuit with resistors instead of light bulbs, and use these laws to predict what the different currents and voltages and resistances are, and then you will check it by building it. So again, if you get something wrong, just go back and rethink why it was wrong. I'm checking the process, not that you have the right answer for the predictions. Now let's look at the second assignment, which is when we have a series circuit. I'll start off by writing out the Kirchhoff's laws for a series circuit. So in series, now we just have one path, so the current's going to be the same everywhere. So my total current will be equal to the current at light bulb 1 or resistor 1, and that'll be equal to the current at the second, and so on for however many light bulbs or resistors I have. But the voltage is different for series because this is my voltage rise. It gives the energy or the voltage to the electrons. The loads have the drop. The voltage drop is going to be split between these. So whatever this rise is, the drop will be equal, but it will be a drop instead of a rise. So my total voltage in this circuit will be equal to the voltage drops of all the loads. Here I have 2, but if you had a third one, you'd add the voltage drop in the third load. And lastly, resistance is just equal to the sum of resistance 1 plus resistance 2 plus any other resistors you might have. So that's my Kirchhoff's law for series circuits. So again, you want to build this circuit and analyze it in this assignment. Sorry, I'm just checking my assignment questions. So you want to measure the voltage total, and then voltage 1 and voltage 2 here using the voltmeter. And remember, it has a black and a red terminal, and you have to put that on either side of the object that you're measuring. So a voltmeter has to go on either side of each of these objects. And then the ammeter, just put it right beside in the circuit, and you can see what the current is. You can even use that little one where you can just hold it over the wire and it tells you what the current is. Then you'll measure both the total current and the current at light bulb 1 and light bulb 2. And then we want to see if in question number 2, use the Kirchhoff's voltage law and see if that holds for this circuit. So did the total equal V1 plus V2? Then you're going to predict the current flow if a third light bulb is added to the circuit. So will the current flow be the same? Will it be different? So this is going to be the opposite, a little bit of the opposite to the parallel. If we keep adding more resistors, that's going to resist the flow even more. So if I add a third resistor in, that should resist the flow even more of my circuit. So predict what you think the current flow will be, and then actually add that third light bulb in and see if it matched your prediction. Again, I'm just looking for your reasoning. If you get it wrong, that's okay. Just explain it, and that's great. And then in question 5 for this assignment, you will also have to create a schematic diagram with resistors and a 25 volts battery supply, and complete the analysis. So find V and R, because we know the voltage, V and R and I, and predict all the values of V, I, and R in the circuit. And then we will compare it and actually build the circuit. And again, if you get something wrong, just go back and see what went wrong and figure it out. So the simulation is meant to help you answer the questions. When you submit your answers, I will check them and also give you a link to the solutions to see if you missed anything. Let me know if you have any questions, as always, and happy circuit building.